Since the birth of reservoir engineering, engineers and geologists have been integrating reservoirs to determine the volumes of oil and gas in place. Usually the procedure involves contouring the pertinent variables and planimetering them, which is mechanical integration. With computers and numerical integrating, we can bypass the limitations of planimetering. Original oil in place is equal to the product of thickness times net to gross ratio times porosity times 1 minus saturation. If we know the oil in place at each individual cell, and if we add up all of the cells within the polygon area, the total original oil in place will be equal to the summation of those cells. This is an example of numerical integration. Interpolation or extrapolation is the mathematical process of making estimates. This process is used in contouring and in integration, since both require estimating values for original oil in place at locations where it is not known. Algorithms for making estimates typically present the following problem. Number one, variables are used to obtain a product, and the product, that is, the combined variable, is used to obtain interpolated values at unknown locations. The result of this is not the same as 2 when the variables are first interpolated or extrapolated at these unknown locations, and then the product is made. The issue is, should we use option 1 or option 2? Before computers, many engineers and geologists were using option 1 to simplify the process of integration. That is, they were contouring combined variables. What is a combined variable? Well, net pay is a combined variable. It's the product of gross thickness times net to gross ratio. Net pore volume is a combined variable. Original oil in place certainly is a combined variable because it is the product of a number of separate independent variables. While this simplification may have saved time, its justification needs to be reassessed. For with computers, time is no longer an issue, but quality and consistency of results are. It can be shown that by choosing option 2, all of the integrals mentioned above are automatically consistent with each other, whereas option 1 does not guarantee this. Furthermore, when we map individual variables, we usually have a better feel for proper trends than we do when mapping combined variables. A comparison between option 1 and option 2 for calculating net pay when the edge of the reservoir is involved is shown graphically in figure 1. In this linear example, we have 2 wells. Gross thickness is trending toward 0. Net to gross ratio is increasing as gross thickness is decreasing. If we interpolate or extrapolate gross thickness, it goes to 0 and defines the edge of the field. If we interpolate or extrapolate net to gross ratio, it does not go to 0. If we calculate net pay by multiplying net to gross ratio and thickness at each well and mapping the product, that product extends beyond the edge of the field. However, if we map gross thickness and net to gross ratio separately and then calculate the product, that product properly goes to 0 at the edge of the field. Mathematically, the reason for the difference is as follows. The integral of the product is not equal to the product of the integrals. We can illustrate these concepts with an example in the following figures where we are mapping a channel sand. Here's the gross sand isopack. It is thick in the middle of the channel and wedges out at the edge of the channel. Here's net to gross ratio, which is lower on the outer arm of the channel and higher on the inner arm of the channel. If we take and map the product of those two, the combined net pay looks like this, and the edge of the channel is not congruent with the actual edge of the channel. However, if we map net to gross ratio and gross thickness at each cell, the reservoir does correctly go to the edge of the channel and goes to the independent net pay goes to 0 at the end of the edge of the channel. If we look at the net pay difference, we see that there is no difference at every well point, and there are profound differences away from wells. We might say that by mapping combined variables, we're right at every well point and wrong everywhere else. In cross-section, the blue line is the gross thickness, the green line is the net to gross ratio, the red line is the correctly taken product of gross thickness times net to gross ratio at each cell point, and the cyan line is the incorrect product of combined variables. So what's the bottom line regarding integration? If you contour net pay, porosity thickness, net porous thickness, original oil in place, caveat emptor, let the buyer beware. Rather, always contour your independent variables independently and take the product at integration time.